Welcome to my presentation. Today we are diving into Trigonometry 1, whereby we shall explore the basics of angles, triangles, and how trigonometric ratios connect them. Welcome. Trigonometry is the branch in mathematics concerned with the relationship between the sides and the angles of triangles. In trigonometry, Greek letters are used to indicate in a general way the sizes of various angles. This one is called alpha, this is called beta, this is called gamma, this is called delta, this is called theta, this is called omega. We move to trigonometric ratios and we start with the tangent of an acute angle. Consider triangle, a right-angled triangle OBQ, where we have OB as given 10 meters, BQ 9 meters, and we have our angle theta. We can now produce OB to an exterior point and OQ to an exterior point as indicated below. After considering triangle OQB, when we produce OQ to T and OB to V, we draw two parallels to BQ, that is RC and PA. We get very similar triangles, that is OAP, OBQ, and OCR. When we have similar triangles, the ratio of the corresponding sides is equal. That is, PA over OA is equals to QB over OB, which is equals to RC all over OC, which is equals to 9 over 10, which gives us 0.9. This ratio of the corresponding sides is the one that we call the tangent of the acute angle theta. So the tangent of theta is equals to 9 over 10, which is equal to 0.9. So this ratio of the corresponding sides is what we call the tangent of the angle theta. The tangent of an angle depends on the size of the angle only. It depends on the size of the angle only, in our case angle theta. Even if you make the angle bigger, the constant ratios remain the same. The vertical side BQ is opposite angle theta, and the adjacent side, the length OB is adjacent to the angle theta. Therefore, the tangent of angle theta is given by the opposite side all over the adjacent side. And in our case, we have the opposite side as BQ and the adjacent side as OB. Gives us 9 all over 10, which is equal to 0.9. 1 degree is divided into 60 equal parts called minutes. In symbols we write 1 degree is equal to 60 minutes. We have examples, and we asked the first one, Roman 1, to convert 30.5 degrees to degrees and minutes. Then the second question we asked to express 15 degrees, 25 minutes into degrees only. The third one we asked to find the value of 15 degrees, that 2 minutes plus 18 degrees, 41 minutes. And the fourth one we asked to find the value of 48 degrees, 24 minutes minus 25 degrees, 35 minutes. Solution. Let's start with the first one. We are given 30.5 degrees. So we have 30 plus, we have 0.5 multiplied by 60, because every degree has 60 minutes. So we want to convert this one, the decimal part, into minutes. This gives us 30 plus, we have 30 degrees, then we have 30 minutes, because 0.5 times 60 is 30. So that gives us 30 minutes. Part 2, we have to express 15 degrees, 25 minutes into degrees only. So this will be 15 degrees plus, we have 25 minutes. To convert this one to degrees, you divide by 60. So this is equals to 15 degrees plus, this is 0.4 degrees. So it gives us 15.4 degrees. Number 3 has to find the value of 15 degrees 32 minutes plus 18 degrees 40 minutes. So we add, first of all we add the degrees. So we have 15 degrees plus 18 degrees. Then the next one, we add 32 minutes plus 40 minutes. If you add 32 minutes plus 40 minutes, we get 62 minutes. Therefore, we have 1 degree there. So we add the degrees first. We have 15 degrees and 18 degrees. That gives us 33 degrees. Then we have the minutes. The minutes now we have 32 minutes plus 40 minutes. That gives us 72 minutes. In 72 minutes, we have 1 degree of 60. So we have 72 minus 60. So we'll have 1 degree and then 12 minutes. That degree now we take it to 33. So that we'll have 34 degrees, 12 minutes. So number 3, we are finding the value of 15 degrees, 32 minutes, plus 18 degrees, plus 40 minutes. 40 minutes. So we add the degrees. So this will be 15 degrees plus 18 degrees plus 32 minutes plus 40 minutes. So this is equals to, we have the degrees, we have 33 degrees plus, this is 72, we have 60 minutes plus 12 minutes, because 32 plus 40 gives us 72. 72, we have, in 72 minutes we have 60 minutes and we have 12 minutes. 60 minutes is 1 degree, so this 1 degree we add it to 33, so that we'll have 34 degrees, 12 minutes. Number 4, we have to find the value of 48 degrees, 24 minutes minus 25 degrees, 35 minutes. So we subtract the degrees first, so we'll have 48 degrees minus 25 degrees, then we have 24 minutes minus 35 minutes. 48 minus 25, that gives us 23 minutes, plus now we have 24 minutes minus 35 minutes. 24 minutes you cannot take away 35 minutes from 24 minutes. So we need to borrow 60 minutes from 23, so that we'll be left with 22 degrees. This becomes 22 degrees plus 60 minutes plus 24 minutes minus 35. This gives me 84 minutes. 84 minutes minus 35 minutes. So that one gives me 49 minutes. You have 22 degrees plus 60 minutes plus 24 minutes minus 35. So in my case, I have 84 minutes minus 35 minutes, which gives me 49 minutes. Therefore, the answer is here 22 degrees, 49 minutes. The table of tangents is read in the same way that table of logarithms is read. We have to find the tangent of 67 degrees. You go to the table of tangents, open page 11. On page 11, you go to the row that is written 67. You go to the 67 row, main column 0. Down there, where we have row 67 and main column 0, you read the value as it is. That is 2.3559. Now finding the tangent of 60.55 degrees. We go to the same page 11. Our low is low 60, low written 60. Then the main column 5. The main column 5. We go down where the low 60 and the main column 5 meet. You read that value, which is 1.7675. 1.7675. That is what we get when we have the 60th row and the main column 5. That gives us 1.766. But there's a 5 that is remaining here. So this 5, we get it from the difference column. The far edge, the difference column. Following the same row, we'll have the far edge where we have 5. 5 gives us 36. The instruction says you add up there. So 36. You add. This gives us 11, column 1, 11, 7, 7, 1. This now gives us the tangent of 60.55. In number C, we asked to find the tangent of 38 degrees, 53 minutes. So we convert minutes first to degrees. So this will give us 38 degrees plus 53 divided by 60 to make it degrees. So this becomes 38 degrees plus, when you divide 53 by 60, you get 0.88. 0.88. So in total we get 38.88 degrees. All these are degrees also. Now we are finding the tangent of 38.88 degrees. 38.88 degrees. We go to the tables. We want 38. So this, we find it in page 10. 10 of natural tangents. Go to the column written 38. Then finding the tangent of 38.88 degrees. We go to the column on page 10. We go to the column written 38. Then finding the tangent of 38.88. We go to the row written 38. Main column 8. Main column 8. That gives us 0.804. 0.8040. 0.8040. That is the main column where we have 8. Then we go to the difference column following the same law. Different column where we have 8. 8 gives us 23. So we add 23 as per the instructions. So we add 23. So this gives us 36080. So we have 0.8063. We also solve for x. From our diagram, we are given the angle and we are given the opposite side of the adjustment. From our definition, tangent of an angle at 5 degrees is always equal to the opposite side all over the adjacent side. So it will follow that x cross multiply x times tangent of 35 is equal to 4. So x is equal to 4 divided by the tangent of 35. From the tables, we read the tangent of 35. Then we go to the column that is written 35, the column written 35, and 35, the main column is 0. So the angle, so we read the value as it is, which is 0.7002. So that is the value of x is equal to 4 divided by 0.7002. we find that x is equal to 4 divided by 0.7220. We go to the logarithm of numbers in base 10, page 2, and we get the logarithm of 4. We go to the row written 4, the main column 0, so we read the value as it is, which is 0.6021. In the next value, we have 0.7001, and we see that now the power of 10 is -1. Therefore, the characteristic is bar 1. Then we move to 7, which is in page 3. Page 3, the column written 7.0. In the next number, we have 0.7002. So we go to the column, we go to page 3, then we consider the row written 7.00, that gives us 8451 as the logarithm. So it will be 0.8451. 8451. We are dealing with the division, therefore we subtract the logs. That is 0. This 12 minus 5 we get 7. Left 9 here minus 4 we get 5. We left 5 there. We borrow 1 from 0. 15 minus 8 we have 7. We are left with -1 here. -1 minus -1, that is 0. -1 minus -1. This becomes positive. It will be -1 plus 1, which is 0. This now gives us 10 to the power 0 times. We go now to the logarithm tables. Logarithm tables, that is page 4 and page 5. We are interested in 0.7570. 0.7570. The one that is nearer to that is 499. We have from the logarithm tables, we read the nearest value, which is 0.7568, and then we go to the difference column to get 2, where there is 2, which is giving us 2 gives us 3. So we add. Therefore, the analog here is 5 point. We move to the tables of logarithms, page 5, because we want to get the analog of 0.7570. So 0.75. We go to the row that is written 0.75. 0.75. Then the main column 7. 75, the main column 7 gives us 5.751. Main column, we have the row 0.75, main column, we have 7, gives us 5715. So 5.715. When you multiply this one by 10 to the power 0, 10 to the power 0 is 1. The answer is 5.715. Sine and cosine of an acute angle. We consider a right angle triangle with the acute angle theta at B. The side BC is adjacent to the angle theta, and the side AC is opposite side of angle theta, and the longest side AB is our hypotenuse. Remember the ratio, the constant ratio that we had, where we had the opposite side and the adjacent side of that angle. That ratio gives us the tangent, which is AC all over BC. That ratio, AC over BC, gives us the tangent of the angle theta. Now the ratio opposite side over the hypotenuse, opposite side of the hypotenuse, in our case, it is AC over AB. This ratio, opposite side over the hypotenuse, in our case, AC over BC, the ratio, opposite side over the hypotenuse, which in our case is AC all over AB, is called sine of angle theta. Sine of angle theta, written as theta is equal to opposite side the hypotenuse. The ratio adjacent side all over the hypotenuse. In our case, it is BC all over BA. Is called the cosine of angle theta. Cos theta is equals to adjacent side all over the hypotenuse. Sine and cosine of an acute angle. Consider triangle ABC, which is a right angle triangle with angle theta at B. The side opposite the angle theta, the opposite side, AC, then the side that is adjacent to the theta, angle theta is called the adjacent side, and then you have the longest side AB as the hypotenuse. The ratio opposite side over the hypotenuse, that is AC over AB, opposite AC over AB, which is the hypotenuse, is called the sine of angle theta. The ratio adjacent side over hypotenuse, that is BC over BA, is called the cosine of angle theta. Sine and cosine tables are read and used in the same way as tables of tangent. Note, as the angle increases from 0 to 90 degrees, their sines increases from 0 to 1, and their cosines decreases from 1 to 0. This means that the values in the difference column in the sine tables have to be added, while those in the cosine tables have to be subtracted. Example, use tables to find the values of A, sine 53.45 degrees, and B, cosine of 71.25 degrees. Solution, we have A, sine of 53.45 degrees. We go to the tables of sine, row 53, tables of sine. We'll go to row 53, main column is 4. Where we have main column 4, we read 0.8028. Then on the same row, we move to the difference column, and the difference column where we have 5, we read 5. The instructions are you add, therefore we add. And adding, we have 3308.0. Therefore, the sine of 53.45 degrees is equal to 0.8033. In the next part B, we are finding the cosine of 71.25 degrees. We go to the cosine tables. We go to the 71 row. Row 71, main column 2. Row 71, main column, row 71, main column 2. We have main column 2, we have 0.3223. And following the same row, we go to the difference column where we have 5. 5 gives us 8, and instructions are subtract. Therefore, we'll have 0.3223 minus 8. 13 minus 8 to get 5, we're left with 1, then 2, 3, 0.3215. Therefore, the cosine of 71.25 is equal to 0.3215. Angles which add up to 90 degrees are called complementary angles. For example, 30 and 60, 20 and 70, 40, and 50, etc. All these are complementary angles because when you add them, they give you 90 degrees. From the table given, you can see that we have angles in degrees here, and we have the complementary angle. 30 is complementary to 60 because when you add 30 and 60, you get 90 degrees. 45 plus 45, 90 degrees. 50 degrees plus 40 degrees, 90 degrees. 80 degrees plus 10 degrees, we have 90 degrees. You can see that the sine of 30, which is 0.5, is the same as the cosine of 60. And the cosine of 30 is the same as the sine of 60. It will follow with all the other angles given here. The sine of 45 is the same as the cosine of 45. The cosine of 45 is the same as the cosine of 45 because the angles are the same. When you go to 50, you find that the sine of 50, which is 0.7660, is the same as the cosine of 40, is the same as the cosine of 40. And the cosine of 50 is the same as the sine of 40. Go to the last one, 80 degrees. We have that, we see that the sine of 80 is the same as the cosine of 10 because the two are complementary angles. And it will follow that the cosine of 80 is the same as the sine of 10 degrees. Thus, for any complementary angles, A and B, sine of A is equal to cosine of B. That is to say, sine theta is equal to cosine of 60. Cosine of A is equal to sine B. As you have seen earlier from the table, cosine of 30 is equal to sine of 60. Therefore, for any angle theta, cosine of theta is always equal to the sine into bracket 90 degrees minus theta. Taking the example of 30, it means that the cosine of 30 degrees is always equal to the sine of into bracket 90 degrees minus 30 degrees, which is equal to the sine of 60 degrees. Then the next one, sine theta is always equal to cosine into bracket 90 degrees minus theta. Taking the example of 30 degrees as theta, we will have sine theta, sine 30 degrees is equal to cosine into bracket 90 degrees minus 30 degrees, which is equal to cosine of 60 degrees. Example, solve the equations. We are given A, sin x is equal to sine 37 degrees. B, cos y is equal to sine 72 degrees. C, cos x is equal to sine 5x. And D, sine into bracket 90 degrees minus x, close the bracket, is equal to 0.8. Then you have to find tan of x. A, sin x is equal to sine 37 degrees. This is sine, and the other side we have sine. Therefore, our x is equal to 37 degrees. Number B, we have cosine of y is equal to sine of 72 degrees. We know that sine of 72, we need the complementary angle of 72, which is, now will be the cosine of y will be equal to cosine of 18, because the sine of 72 degrees is equal to the cosine of the complementary of 72, which is 18. Therefore, we have cosine on this side and cosine on the other side. Therefore, y is equal to 18. Then number C, we have cosine of x is equal to sine of 5x. The complementary of 5x will be cosine of x is equal to cosine of into bracket 90 minus 5x. Therefore, we have cosine on this side and cosine on the side. So we can drop the cosine, so we have x is equal to 90 minus 5x. Taking x to this side, we'll have x plus 5x is equal to 90. 6x is equal to 90. So x is equals to 15. Then we go to number D. Number D, we are given sine of 90 degrees minus x is equals to 0.8, which is the same as 8 over 10. This is equal to 4 over 5. And the sine of 90 minus x is the same as the cosine of x. So the cosine of x is equal to over 5. So the tangent of x will be given by, we make a sketch of a right angle triangle here. So if this one is theta x, so the cosine of x is opposite over hypotenuse. So the adjacent is 3. Therefore, the tangent is opposite over adjacent. So it is 4 over 3. Number D, we are given sine into bracket 90 degrees minus x is equal to 8 over 10, which is equal to over 5. Sine into bracket 90 degrees minus x is the same as the cosine of x, because x is the complementary of this. And the cosine of x is equal to over 5. So using a rough sketch of a right angle triangle, cosine is adjacent over hypotenuse. Therefore, the opposite side is 3. And therefore, tan x is opposite over adjacent. So it will be 3 all over 4. The relationship between sine, cosine, and tangent. We consider triangle ABC, and we have angle theta here. We label the opposite side of A using small letter A, opposite side of C, small letter C, opposite of B, small letter B, such that now we'll use the letters ABC to denote the opposite side, hypotenuse, and the adjacent. Sin theta is equals to opposite side A all over the hypotenuse. This means our A, the opposite side, is equals to C multiplied by sin theta. Our cosine theta, which is adjacent over hypotenuse, will be denoted by B over adjacent over hypotenuse, B over C. This means our C is equals to, this means our B is equals to C cosine theta. And theta will be equals to opposite side over the adjacent. So it will be A all over B. In this case, our A is C sin theta. So we'll have C sin theta all over, our B is C cos theta. We can cancel out the C. Cancelling out the C, we'll have that tan theta is equal to sin theta all over cos theta. Trigonometric ratios of special angles, 30 degrees, 45 degrees, 60 degrees. We use a right isosceles triangle to get the trigonometric ratios of 45 degrees. A right isosceles triangle has two sides equal. This side is equal to this side. And then we have the hypotenuse. 90 degrees, 45, 45. So how do you get the hypotenuse? We usually get the hypotenuse by squaring the base plus the vertical height, then you get the square root. So this one will be square root of 2x squared, which will be given by square root of 2 times square root of x squared. So this becomes square root of 2. Square root of x squared is x times x. We get x root 2 as the hypotenuse. From the diagram, the right isosceles triangle, we can get that now the sine of 45 will be given by the opposite side over the hypotenuse. So it will be x all over hypotenuse is x root 2, which will be equals to 1 all over root 2. Because this x will cancel with the other x. Then cosine of 45 degrees will be given by, cosine is adjacent over hypotenuse. So it will be x all over x root 2, which is equal to 1 all over root 2. Tangent of 45 degrees will be given by Tangent is opposite side over the adjacent side. So it will be x over x, which is equal to 1. To get trigonometric ratio of special angles, that is 30 and 60, we use any equilateral triangle. In this case, I'm using an equilateral triangle, two sides of 2 units. That you have 2, 2, 2. The angles are 60. Then I drop a perpendicular from B to the base AC to divide this angle B into 30, 30. After that, I need to find the height of this perpendicular height. We have the base as 1 and the hypotenuse are 2. How do you get the height? So we get 2 squared. To get trigonometric ratios of special angles 30 and 60, we consider any equilateral triangle. In our case here, we have an equilateral triangle whose units are 2 units, 2 units, 2 units. An equilateral triangle, all the angles are equal. They are 60, 60, 60. The first step is to drop a perpendicular from B to the base AC to give so that the perpendicular divides the angle into 2, 30 and 30 degrees. After that, we need to find the height. Now we have a right angle triangle, right angle triangle BDC. To get the vertical height, we need the hypotenuse and the base. Therefore, we'll have 2 squared minus 1 squared. Then you find the square root to give us the vertical height. So this will be 4 minus 1. You get the square root, so it will be the square root of 3. That's how we got the height as root 3. From there now, we proceed to the sine, cosine, and tangent of the angle 30 and 60. Sine of 30 degrees will be opposite over hypotenuse. So it will be equal to the cosine of 30 degrees will be adjacent, which is root 3 all over hypotenuse. So it will be root 3 all over 2. Then the tangent of 30 degrees, the tangent is always equal to opposite side over the adjacent. So it will be equal to 1 all over root 3. Sine of 60 degrees will be given by sine is opposite over hypotenuse. So it will be root 3 all over 2. Then the cosine of 60 degrees will be given by the cosine is adjacent over hypotenuse. So it will be 1 over 2. Tangent of 60 degrees will be given by the tangent is opposite over adjacent. So it will be root of 3. Note it will follow that the complementary angles, like now we have the sine of 30 degrees is half. If you go to the cosine now of 60, it is still half. Cosine of 30 is root 3 over 2. If you go to the sine of 30, and the sine of 60, it is still the same, root 3 over 2. Example given here, you have to simplify 4 cos 45 times sine 60, then part 2, 3 cos 30 plus cos 60 degrees. Then question 2, we are given an isosceles triangle is such that AB is equal to AC is equal to 8 centimeters. If the perpendicular distance from A to BC is 6 centimeters, find 1, Roman 1, the length of BC, Roman 2, angle BC. Solution. We have 4. We are multiplying by cosine of 45 is 1 over root 2 times the sine of 60, which is root 3 over 2. We cancel by 2, 1, by 2, 2. So we get 2 root 3 all over root 2 as the solution. Then for Roman 2, we substitute cosine 30 degrees with root 3 over 2. So it will be 3 times root 3 over 2 plus cosine of 60, which is a half. The LCM is 2. So you have 2 there. 2 when you divide by 2, you get 1, multiply by 3, you have 3 root 2 plus 2 divided by 2 is 1, multiplied by 1 is 1. So the solution is 3 root 3 plus 1 all over 2. Question number 2. We have an isosceles triangle ABC. AB is 8 centimeters is equal to AC 8 centimeters. Then we are given that the perpendicular from A to BC is 6 centimeters. So we let the perpendicular to drop from A to BC and to meet BC at D. Since it is an isosceles triangle, the perpendicular bisector will divide the base into 2 equal parts. Note also that for any isosceles triangle, the base angles are equal. So we have angle theta here and angle theta here. We are asked to find the length of BC. So we want to find the length BC. BC will be equal to BD plus DC because the perpendicular from A to BC divide the base into 2 equal sides. Our DC is the base of triangle ABC. Using the Pythagoras theorem, hypotenuse squared minus the height squared should give us the base squared as the square root. So we'll have square root of 8 squared minus 6 squared. This will be the square root of 64 minus 36, which is the square root of 28. From the square root tables, we can read the square root of 28 directly as 5.2918. Therefore, our BC will be equal to twice DC. So it will be 2 times 5.2918, which is equal to 10.583. Part 2 has to find the angle BAC. Angle BAC, this angle. The base angles are theta and the other one is theta. So theta plus theta, if you subtract that one from 180, should give us angle BAC because the sum angles of a triangle are 180 degrees. So the first step is to calculate angle theta. Angle theta, using the sine rule, sine of theta is equal to opposite over hypotenuse. So the sine of theta is equal to 6 over 8, which is equal to 3 over 4, which is equal to 0.75. Our theta is equal to 48.59. How do we get 48.59? We go to the sine tables. From the sine tables, we go to the row that is written 0.7. So to get theta here, which is 48.59, we go to the main column, we lead the number that will give us 0.75 or near to 0.75. And the number we have there is 0.7490. The number we have there is 0.7490. Where we have that number, 0.7490, which is near to 0.75, on that row, where we have the main column, we have 48. We have 48. We have 48.5. And then when we go to the difference column, the difference of 10, that is giving us, the difference of 10, which is giving us 3. So when you add from the table of cosines, we have a number that is nearer to 0.75, which is 0.749, and that one gives us 48, in the 48 row, 0.5. There is a difference of 10. That difference of 10, when you follow the same row of 48, it gives us 9. The instruction is addition. We add 9 and you get the angle as 48.59. When we get theta as 48.59, we need the other theta also. This theta plus this theta, which is 2 theta, gives us 97.10 degrees. Therefore, angle BAC, this angle, will be given by 180 minus 97.10, which is equal to 82.9 degrees. Sum of the angles in a triangle, which is equal to 180. The whole number part of the logarithm is called the characteristic, and the decimal part is called the mantissa. Now we have introduced characteristic, and the mantissa. Logarithm of tangents, sine and cosines. We have an example. Evaluate 11.4 multiplied by sine of 32.8 degrees. From the tables, the sine of 32.8 degrees is equal to 0.5417. Therefore, 11.4 sine of 32.8 is given by 11.4 times 0.5417. Going to the logarithm tables, we have the number and then we have the log. 11.4 in standard form is 1.14 times 10 to power 1. The power of 10 becomes a characteristic, and then the logarithm of 1.14 becomes the mantissa. So that is 1.0569. 1 is the characteristic, then 0.569 is the mantissa. When you have 0.5417, you write this one in standard form as 5.417 times 10 to the power negative 1. The power of 10, which is negative 1, becomes a characteristic, so you write it as power 1, because it is only the characteristic that is negative. So we write the negative on top of 1. The other part is positive. In multiplication, we add the logs. So we add the logs, we get 0.7907. The characteristic, this is 17, 1, 6 plus 3 plus 1 is 10, carry 1. This is 6 plus 3 is 9, 0 plus 7 is 7. Then we have 1 plus negative 1 is 0. So we have the characteristic as 0, so it will be 10 to the power 0 times the antilog of 7907 is 6.176. Therefore, the number we get as a solution is 6.176. Or alternatively, you have now the number as 11.4 and the logarithm is 1.0569. You can read directly from the logarithm of sines. The logarithm of sines. So that we have the number as 32.8. Then we read directly from the logarithm of sines, and we go to the row that is written 32. When you have the row that is written 32, then point, we go to the main column, 8, we'll get 0.7338, 1.7338. You can read directly from the logarithm of sines, and it will give us 1.7338. Instead of going through the long process, you go directly, you read from the logarithm of sines, and you get it. Then you add, you get the same solution. Application of trigonometry. Example 1. The observers A and B, 500 meters apart, observe a kite in the same vertical plane and from the same side of 8. The angles of elevation of the kite are 30 degrees and 20 degrees respectively. Find the height of the kite disregarding the height of the observers. Solution. We make a rough sketch diagram. We have the observer B and observer A. They are 500 meters apart. Observer B, angle of elevation is 20 degrees. Observer A, angle of elevation is 30 degrees. We want to get this height of the kite. We have from A to the bottom of the kite, to the bottom of the vertical height, that distance is unknown. So we call it x meters. We call it x meters, we have 100 meters here. Using trigonometry, we have that the tangent of 30 degrees is opposite over adjacent. So the tan of 30 is height over x. This means that our height is x multiplied by the tangent of 30. Using observer B, we have that now that the height opposite over adjacent, tangent of 20 degrees will be equal to the height all over x plus 500. opposite over the adjacent. The adjacent is x plus 500. This means our height is equals to x plus 500 times the tangent of 20. Therefore, this height and this height, so we equate the two equations. X tan 30 degrees is equals to x plus 500 times tangent of 20. Tangent of 30 from the tables is 0.5774. Multiplied by x is equals to the tangent of 20, which is 0.3640. We are multiplying by our x times 500. Opening the brackets, we'll have 0.3640 times x plus 0.3640 times 500 is 182. Put the right terms together, we take this other side, so 0.5774x minus 0.3640x is equals to 182. When you subtract this minus this, we get 0.2134x is equals to 182. So we divide by 0.2134 on both sides, so that we are left with x is equals to 182 divided by 0.2134, which gives us our x as 852.86 meters. That is our x. 852.86 meters. We have our x. Now that we have our x, we can now get the height. The height is x times 30. So our height will be given by our x, which is 852.86 meters, multiplied by the tangent of 30, which is 0.5774. Therefore, the height will be equals to x times the tangent of 30, which is 0.5774, and that gives us 492.44 meters. Example 2, finding the area of a triangle. Consider any triangle ABC with sides A, B, and C. From definition, the area of a triangle is a half base times height. We have a triangle ABC. Dropping a perpendicular from A to BC, we have to meet BC at D. We have triangle ADC. Using triangle ACD, we'll find that sine of angle C is equal to opposite by hypotenuse, so it will be height over B. Therefore, the height is equals to B times the sine of C. In this case, the area of triangle ABC will be equal to a half base times height. So it will be half A times our height, which is B sine C. Using triangle BQC, triangle BQC will have our height as CQ, and then the sine of B will be the opposite side, which is the height QC, all over the hypotenuse is A. Therefore, our height is equal to A sine B, cross multiplying. And the area of triangle ABC will be half AC sine B. Using triangle AKB, that triangle, we have our height as BK. Therefore, the sine of A will be the opposite, that is BK, all over the hypotenuse, which is C. And in that case, the height is C sine A. And therefore, the area of ABC will be half our base is B, times the height, which is C sine A. In conclusion, we can see that the area of the triangle will be equals to, the area of the triangle ABC will be equals to a half BC sine A, which is also equal to a half AC sine B, and it is also equal to a half AB sine C.